Hello viewers and welcome to a new STM32 World tutorial video. Now in this video we will be talking about flashing STM32 MCUs. If you already know how to flash and you know ST-Link, etc., you might give this video a skip, a pass. This video is particularly targeting newcomers that find it confusing how you actually flash STM32. A lot of that confusion originates from a lot of newcomers having tried Arduino before using STM32. So let's briefly have a look at Arduino, how Arduino works, and let's go back and look at one of the early Arduinos, which was the early Arduino. Now let's look at the official release 2 here, Arduino Uno, which is the first one. It have an Atmega something, I don't remember, a small 8-bit MCU. You will see that the board itself, you hook it up with the USB connector. This chip is actually a USB to serial because the Atmega 8-bit processor doesn't have a USB peripheral in it. So this one converts that into a serial line, and you're using that serial line to flash your, I believe Arduino call them sketches, firmware, and so on and so forth. If you're always using the Arduino environment and you are not making any horrible mistakes or creative stuff, this will work. But it works, but it's important to know that it works because there is a small bootloader installed in the Atmega MCU that actually, so your application is relocated. If you're watching some of my earlier videos on how to make a DFU bootloader on STM32, well, it's the same technology except this is much simpler and much smaller. But the important part here is that if you can see this is actually, I think, in a socket, might be in a socket. In the earlier ones it was definitely in a socket. You can actually change the MCU on these boards. If you bought a new MCU off the shelf and put it in, this would not work. It would need to have the bootloader flashed in the chip, and that is a somewhat complicated affair. If we look at the Arduino documentation about the bootloader, it's a small piece of software that allows uploading on sketches, and it comes pre-programmed on the microcontrollers on Arduino boards. But if you need to burn a new one, you will need to buy an AVR ISP. And if we look at an AVR ISP, there is one here, for example, the Admiral Ice programmer. They're not cheap. $200. There is a basic one without the different cables for $148 for some. I'm sure you can get some fake ones on from China. And to be honest, it is possible to flash this with another Arduino that is working. But basically what you do is you use this IC in-circuit serial programming port over here. It's essentially an SPI port. You will hook it up to this and you will flash the bootloader in the chip using either another Arduino or one of these ICE devices, which is, yeah, it is Admiral's programming tool. Now, the STM32 is not that different in that aspect. The only difference is we are not normally relying on a bootloader being put into the STM32 because there's so many variants of STM32. A lot of bootloaders would have to be developed, and indeed they have tried to do that for some boards on Arduino, but a much better choice is to use a so-called ST-Link device. That is really the go-to way of flashing an STM32. Now, ST-Link is STM's variant of the Atmel Ice, but contrary to the Atmel Ice, these are really quite dirt cheap. If we look at the original V2, you can see here they are about $22. A newer version V3 is about $36, and at least the V2 can be found on AliExpress in Chinese clones. So let's, we were here. Let's look at the different types of ST-Link devices you can get. The original was called ST-Link. Well, there must have been a V1 at some point. I have never seen one. It must be so many years ago. But I have seen these ST-Link V2, which are the ones shown over here. There were two different versions. There was this one, the left one, that was not isolated. That means you could create a lot of sparks if you didn't know what you're doing. And then you had an isolated version here, which was slightly more expensive. But there was two versions. One thing these two had in common is, even though these boxes are white and they are big, and there is no legend on the I/O port. There is no legend on the box enclosure, and I really don't understand what went through the head of ST when they designed this device. Simple fact is, every time I do have one of these, and every time I use it, which is now never, I have to Google the pinout. I have it somewhere, didn't I? There, right? Yeah, I will have to go in and say ST-Link V2 pinout, and then I would get something like this showing the pinout, and then I'll have to make sure I get it the right way around. And it's horrible. I don't understand why they didn't put a legend on it. Now, these exact devices, or at least almost exact devices, you can buy some Chinese clones, and these are seriously cheap as chips, no pun intended. They cost roughly $1.50 to $2 a piece, and contrary to the official one, these actually do have a legend on the box, so it's quite easy to hook them up. These I have used quite a lot, and they work really well, most of them. I have seen one or two that refuse to update at some point, but they are running the same firmware. I should mention that these devices over here, they are built around an STM32F103CB. And as such, and since the schematic is readily available, it's quite easy to clone these devices and just throw ST's original firmware into them, and that is essentially what these guys have done. The clones, the cheap clones, have two problems. The SVO port, the serial wire viewer, is not pulled out, and it doesn't have a serial. That is it. So on the Nucleo boards, this part up here is actually an ST-Link device as well. These are sort of in between the V2 and the newer V3. These are officially identified as version 2-1, and these devices actually have serial port built in. So you can, when you hook them into the USB port, they'll show up as a serial port as well as the ST-Link device. These are quite convenient, and it is the reason, the fact that these are on all the Nucleo boards. As I said, if somebody want to start with ST, don't have a clue, just want to give it a shot, for all that is holy, by ST-Link V2 Nucleo board. It is by far the easiest way to get started. You can later start to experiment with others. You can buy two and you can break one of these. These are designed so they can be broken off and used standalone, and it's a good one. I have actually made my own version 2-1 devices. They are here, the development of that, and what I did was I based it on the schematic that ST provide in the manual of their Nucleo boards, and I simply made my own. And it is working fine, and it's got serial, it's got SVO, it's got the whole lot. Now, if you don't want to get a Nucleo for whatever reason, and you want to develop different, and you don't have the patience of making your own ST-Link device, then by all means buy one of the newer ST-Link V3. There are two that I would seriously consider. There is the V3Z, which is a big one with tons of different options. It can do STM8 as well, I think, so it's a complicated one. I have never had one and I never used it, but it is probably what I would buy. And as I showed you before, they are not overly expensive, $36 for one of those. But you can also get the Mini, which is kind of more like this one up here, and they also probably work really well. So yeah, I would get one of these at a very minimum, or a Nucleo board if I am beginner. I would not mess around with these Chinese clones if I were a beginner, because they don't have serial and they don't have the SVO port. And while these are really, really cheap, they are less than $2. They are available at less than $2 a pop. It is not nice not to have those features. I want to point out that if you are stuck with one and you have a soldering iron and you know what you're doing, it is actually possible to add a little wire on this board and get the SVO pin out on the header. It is possible, but I have actually never done it because it is my eyesight is not good enough to do that stuff anymore. So no. And it's not worth it when you can get one of these really, really, really cheap. So what can you actually do with the ST-Link? Well, if you go back and watch some of the earlier videos, you will see how I'm using this ST-Link to actually single-step debug and watch variables in the MCU even while it is running. In STM32CubeIDE, it's a simple matter of clicking the run button up here and it will flash. And so let's look at the output actually. So what is happening here is using the GDB, that's the debugging server, which is a public open source one, and then it's calling the STM32 programmer, and the programmer is then flashing the device, the firmware into the device. Now this programmer, the STM32CubeProgrammer, actually exists in a standalone program. So let's have a look at that. I have it installed running. I have it running there. So this is actually the standalone STM32CubeProgrammer. It can be called from the command line, which is what STM32CubeIDE is doing. But you can see that the one I have installed here manually is actually exactly the same version. So this is a version, and we can use this to connect and poke around inside the device. So if we click connect over here, oh, it is already connected. Disconnect, connect, right, no, wrong address. Where is that? So this is the flash address that we normally start our applications at, which is 80000000 in hexadecimal. And you can see here, the first is the stack pointer, which is pointing to the top of the memory, and the next is the reset vector. So this will jump down in the code somewhere and start executing there. What is it? 905. Do we have that? Oh, we don't have that. So anyway, it can be done. We can do all kinds of things. You can poke around in here. You can actually change one bit if you want. In this, it's possible. It's not a problem if you know what you're doing. You can also do a bulk erase. You can click down here. Are you sure you want to do a full chip flash? No, I don't want to do that right now. Let me just show you up, device big, you can see, no, it's not running because I'm connected, but if I disconnect, there, it will start running. If I disconnect STM32Cube, let's reconnect. I want to show you while I'm in here, and this is, I might be a video on its own, but you have something called option bits inside the, you can configure some stuff inside the MCU. And one of the interesting thing is something called readout protection. And I want to show that it's got 3 different readout protection levels. There's a page on the STM32 wiki describing this. Level 0, which is the one we have default, there's no protection, but we can actually read protect the flash, and we can set it to CC, which is level 2, which cannot be reversed. So if you set it at CC, it will never go back. But the interesting part is we can now actually set this to BB in this, and then we can try to apply that. Now something interesting is happening. We got the successfully programmed. Now if we go up and actually try to read our flash like we did before, we will get an error, read data failed. So it cannot read the data. If we disconnect and connect again, read data failed. So we have just disabled the reading. Now, because I used BB and not CC, it is possible to reverse this. Say you want to protect your firmware and you don't want the customers to be able to download it and copy it to new devices. This is what you could do. You could set that BB protection. Now, if this is reversible, which it is, then I hear you say, well, it doesn't protect very much. Well, but it does, because if I set this back to AA now, which I can, so I can apply this, but now you will see something very, very interesting. First of all, it takes a lot longer than before, and that is because it actually erases the entire memory. So if we go up here and read, we are now allowed to read, and it will all be FFFF. This is now a clean device, like it had never been used before, and nothing is running on it. So if we disconnect this, we can now go back and reflash it from STM32. Well, just to show you, right now it's not doing anything, it's not blinking, but if I flash there, you will see we are back to blinking. There. What I wanted to say, one more thing. Yeah, I wanted to show, I mean, it's one of the reasons why you would like the SVO pin. I have showed this a lot of earlier video is you can actually, if you run this through the debugger, you can have breakpoints in the program and it would default always stop at the start of the main. But then if we continue to execute, we can see over here we can actually do live expressions. That means we can look at variables inside our program while it is running, and it's quite quick as well. That is because of that SVO pin, or actually it's not necessary to have SVO for this, but ST-Link can do this. That's yeah, I was saying some crack. So how do you hook up an ST-Link to a development board? Let's kill that and look at the black pill pinout, which is device there. You see, I have the ST-Link, my own ST-Link over here, but it could be one of those Chinese clones if you like. I have hooked it up with 4 wires to the end and 2 wires that go over here. So what is that exactly? Well, if we look at this, you have the programming header down here. It will have the clock, the I/O, 2 pins, which is the SWD serial wire debug pins. It needs 2 pins, and they are hooked up to these 2 pins down here, and they come from the ST-Link. Now you can optionally power the target board, like the black pill board. You can power that on this header as well. But these two, at least the ground wire is a good idea, not to create sparks, but the 3.3 volt, you could easily power this from the USB itself. And if that USB port and the USB port on the ST-Link is using the same hop at least, so they are shared ground, then it is actually not necessary to hook up the ground wire. So you could get away with 2 wires to flash this using an ST-Link. Normally you would hook up at least 3 of these and power from USB, or you will hook up all 4, like indeed I have done here, and you can see there is nothing hooked up to the USB port. So this one is actually powering the black pill board as well. Oops. Yeah. So how do you hook this up to the ST-Link? Well, as I mentioned before, it is a slightly confusing. ST-Link is, at least the old official V2 devices, you have a VDD over here that is a supply voltage. You could supply voltage. You have a ground here, so 18, 19 and 20, pin 19 and 20 hooked up to the target device would work, and then in here you have the clock and the I/O, so 7 and 9. So these 4 pins, 7, 9, 19 and 20, would be hooked up to the black pill board. You also have the SVIM. It's probably that one. I'm actually not sure. I think it's SVIM or either the TDO. I'm actually not sure which port here you would hook up to the SVO to get the serial wire viewer active. I don't know. I haven't. But if you do JTDO, here we go. So JTDO, there. TDO, so it is this pin that you would hook up. It's a JTAG pin, but it also is used for this. I think it's that. That would be my guess. It's worth trying. There's almost impossible to blow anything up. In my case, as you can see, I have also, since my device is a 2-1 device, it also have a serial port, and that is those 2 wires, and they go over here close to the USB on that side. And if we look over here, what do you know? TX1 and RX1, the serial port is on these 2 pins, 8, 9 and 10, and that is what that is hooked up to. But these 2 are not needed for anything except debugging. What I said, A9 and A10, these 2 are not needed except for debugging. Let's see if we can get that running there. So this is a separate serial port, but running in the same device, but hooked up to these 2 pins. So I think I have pretty much said all I want to say. I hope I brought a little more clarification to the somewhat confusing world of how to flash STM32 MCUs. Let me say, this approach and the ST-Link devices work on all STM32 MCUs. They all have that port, the SWD, serial wire debug port. And most devices, even if you buy say a printer or whatever with an STM32 MCU in it, you can follow the PCB, and you will find that port typically in a header somewhere on the board. STM32 device SVD port. Let's see if there's some photos we could use, images. These are mostly development boards. I think this is a plain and I am sure it's got an SVD port pulled out. And you can usually find a header somewhere near this corner where you can find the SVD header. If you can find a couple of test points or whatever, you can start hooking up an ST-Link device, and you can poke around inside the MCU if it doesn't have read protection. If it does have read protection, you can try to switch that off, but then you lose the firmware, so that might not be a good idea. As usual, have a wonderful rest of the day, and please like and subscribe this video if you feel that it was worth your time. Bye bye.